Yeah, I have a few slides about how the smart contracts looks like. I guess you guys already know how blockchain is, how it works, all the stuff. So this crazy thing called smart contracts. For example, the Bitcoin blockchain, it has a pretty cool feature where you can add a very small piece of data on each transaction. So what mainly Ethereum came up with is with this smart contracts addition, where you can actually add much more data on transactions, even like had store functions, and store functions are data, right? Like actually code on different addresses. So this piece of code is going to have a certain behavior, right, on a decentralized network. So this opened the world for any crazy application that you might think of to actually build it in a decentralized network. I mean, this was next level. I remember the first time that I got into Ethereum, I didn't understand it at all. Then 2 months after that, I went again. I understand it. I was like, okay, this is awesome. Right? You can build like anything you want here. So what is a smart contract? A smart contract is a collection of code or functions and data that resides on a specific address on the Ethereum blockchain, right? For example, this little guy, right? We are storing an integer, right, on Ethereum blockchain. So we set the integer that we want to store. We just store a number. The beautiful thing about this is that it's on the blockchain. I mean, you can access it from anywhere. It is uncensored, right? It's like you cannot even you cannot control it. One is there, and all this stuff is being recorded. The transaction that you use to create the smart contract is actually being recorded in the blockchain. All the functions that you call when you want to set the integer is actually saved in the blockchain. The transaction that you use to destroy the smart contract is saved there, so you can actually track everything that happens, right? It's also a ledger, like a record of all the transactions and actions that happen over that smart contract. Well, the contract layout, basically what you have at the beginning of the contract is a version pragma where you set like the compiler version that you should use. Then, of course, you can import files. You can import like different smart contracts. Now we are going to go, after this, we are going to go through our winding tree smart contracts, and we are going to be able to see how the imports work and how do we use it for our winding tree hotel index smart contracts. And then what comments is like, I think most of us here are developers, so we know how this works. It's like, this is like the comment standards. Variable types, this is boring, so let's try to get through it fast. This is different variable type that you have. Also, this is a resume of all the documentation of Solidity. Later, all the resources are going to be in our wiki repository that we have for the hackathon. Everything will be there, and it's much better explained there than me here. But just to go through a quick overview of how does it work. So this is different variable types. This is actually like mappings and arrays that you can use. You have to be careful later of how they're using arrays, because I think right now we support like unfixed size of arrays, dynamically size of arrays. How do we define the functions? The thing is that we have internal and external functions. An internal function is something that you can call it only inside the contract, right? This is pretty much it. We have pure, constant, view, and payable. This is something important. Don't forget to add it. If you are going to have a function where you want to receive Ether, you need to have the payable modifier. If not, it's not going to work, right? It's going to throw an error. Then, pure view, and constant functions, they are. It's all explained later on the documentation. But if you need, if you have a function that you just need to get something from the smart contract, like data that is stored. for example, it's going to be a view function because you don't need to make any, how do you say it? You don't need to compute or calculate anything on the blockchain level, right? On the network level. So this is the one that you are going to use. Well, it's of course, it can return different types of variables. State variables, constructor, and modifier. Okay, this is interesting. This is something that you can execute before each function. For example, this function abort, it will be only to be, it can be called only by the seller, and the seller will be the one who creates a smart contract. When you define your smart contract, the constructor function is the one that you're going to use when the contract is being deployed. So what we are going to do here is we are going to set like the seller variable is going to be the message that sender. It means that the address that is deploying the smart contract. And then this function is going to be able to be called only by the seller. If not, we are going to throw an error. I'm missing something? No, yeah, that's pretty much everything. Structs and events. Events. This is something also cool that you may want to have on your smart contract. An event is something that we can throw on the transaction. Then if you, for example, later, I'm sure that you're going to use Etherscan or some block explorer. Later, you can actually debug all your smart contract by seeing which events have been executed on the function, right? So also it helps you to log some information. I don't know how much time that the events are going to be living on the blockchain, if they're going to get run or not. But yeah, this is something that you definitely want to use. And also structs. This is something also cool. You can define like your own variable structure, right? For example, the seller is going to have an address and amount field, and this is how we create the seller variable, right? On the constructor, we send it on order, right? The first variable is going to be the address, and the next one is going to be the amount. Global variables. These are variables that you can access. You have much more, but this is the one that you are going to be using. For example, now is the current block timestamp message. That value is the amount of ether that you are sending in way, right? In way is the unit that you are using to the minimum amount of ether that you can send. Then message sender, gas. You can access also the data. You can know how much gas you have left on the function that you are executing. Error handling. This is also important. There is a lot of stuff here. Assertions, requires, revert. All of them, they have different. How do you say? They have different consequences, right? Some of them, they're going to return the ether. They're going to return the ether back. All of them, they're going to return the ether back, but it depends on the transaction level of, for example, if it is an internal transaction or not. What is going to happen if the transaction is going to continue or not? All this information later on the Ethereum documentation. I got it from there. It's very well explained. This is just a quick overview. Also, what else can we do? This is just to wrap it up. Also, from a smart contract, you can call other contracts. This is something that we are doing on our smart contracts. I'm going to show you guys. Create contracts from another contract. Another thing that we are doing, for example, from our 1 in 3 index of hotels. Every time that you register a hotel, we create another smart contract for the hotel. You can recover the signer of elliptic curve signatures. This is something also pretty cool. It allows you to work cryptography, right? It's amazing. You can prove very hard mathematical problems. Hash data, of course, send ether between contracts and to any other address. And of course, also you can destroy the contract. This is actually not used very much by the developers, but it's an important thing. Okay, boring. Let's go. okay, this is the 1 in 3 index of smart contracts. This is where we have a registry, for example, of all our hotels, right? All the hotels that are registered on right now the 1 in 3 testing network that we are running right now. So this is we are importing, right? We are importing the abstract 1 in 3 index and the hotel. We need to import the hotel contract because this is one that we are going to create, right? Every time that we want to register a new hotel. Yeah. I was going to talk about the abstract. What's the reason about the abstract? Well, if you look at it, the abstract is just a list of all the functions that you can use on the smart contract. So to interact with the smart contract, the only thing that we need to know is the function names and the parameters that they are going to receive. Why? Because using this, each function has a identifier that is going to be the result of the hash of the function name plus the parameters. So every time you actually call a smart contract, they have I don't know if they changed it, but it was like a few months ago. They have like a switch option, something like that. So they hash. I mean, the first 4 bytes of the transaction is going to be the function signature, it's called, and the EVM is going to know, okay, this is the one, no, this is the one, no. Okay, this is the function that we want to call. The next data that we are saying on the transaction is going to be the parameters of the function that we want to execute. So the idea of the index is that we have this very simple smart contract where you can say, on this address, I have a contract with these functions, and that's it. You don't need all the code to interact with it. You need the code to deploy it. Well, here we have some mappings, right? We are mapping the hotels by index, by the manager. So this is how we use. The thing that you cannot, for example, it's not a very good practice to use a for example, a for condition here to go through all the smart contracts and other stuff. If you have 5 hotels, that's enough. But I mean, that's good. But if you have 1,000, you cannot. Yeah, you cannot. You are going to. You won't be able to execute the function like that, right? The way does it work is like every time that we are executing something on our function, hashing, assigning a new variable, calling another contract, or calling another contract function, we are expending gas, right? So we have 2 things. One is called gas price, and the other thing is gas limit. If I want to call a function, what I'm going to set is the gas limit. This is how much gas I'm willing to spend. And this is how much I'm going to pay for each operation, right? For each amount of computation, if we want to call it like that. So this knows, this is how we pay this shared computation of the network, right? It's not free, right? It has, of course, a cost. The more that you pay, the more that the sooner that it's going to get executed, right? We cannot do a for because of that, yeah? So we have to index all the hotels by everything by, for example, the managers or the index of the hotel, the position of the hotel in the hotel array. So here, okay, this is interesting. The leaf token address. Okay, no, this is not interesting. So events. We have events, of course, that we are going to be throwing on each of our functions and to track what is happening. So if you are listening, for example, to the 1 in 3 smart contract, you can listen to the events. So every time you listen to, you see that a hotel has been called or it has been transferred or deleted, you can actually know all this stuff by just listening to the events of the smart contract. Well, of course, the constructor, we are just setting the length of the hotels to start in 1, because if you try to get a hotel on the hotel address and it's not there, it's going to return you 0 as index. So that's why we are saving the index 0 for a hotel that doesn't exist. Well, for example, the setList token, it can be called only by the owner of the index, right? Register hotel. This is something that we are doing it right now. Later, Jirka and Jacob will give a platform overview, and tomorrow you are going to be able to see all this happening live. They are going to do a demo. So they are not going to show any video. They are just going to do a live demo. And well, this is what we are doing when we register a hotel. For example, we are creating a new smart contract, right? From here, what we are going to see. I think if you see it on Etherscan, you will see you will see this is an internal transaction. When you every time to create a new smart contract, you have to send data to the address 0, and this is this is the data that you want to be deployed on the blockchain. So here on the register hotel, we are going to see an internal transaction to the address 0 with all the data that is going to be analyzed by the EVM and is going to deploy the contract. Once the contract is created, we assign it, right? We push it on our hotels array, we assign it in our index, and we emit the throw the event of hotel register. Then I think that's pretty much it. I mean, it speaks for itself, right? For example, the hotel. First, the hotel needs to exist, and here we see that the message that sender, the one who is executing this function, needs to be the actual owner of the hotel. I mean, the hotel needs to exist. And this is the hotel that we are destroying. Destroying a hotel, that's not nice. Call hotel. Yeah, this is also another thing that we are doing on 1.3. All the calls, I mean, all the interactions with our smart contracts go through one contract, go through this index, right? This way, we can track all the transactions, everything that is happening. So all the transactions that are happening with the 1.3 index is it's everything that is happening on the blockchain level in 1.3, because this is the only way to communicate with the hotel contract is through this contract, through the index. And the only one who can call it is the hotel owner, or well, the index owner for now. So this is, for example, this is the data that we want to execute on the hotel contract. So now we are going to see the hotel contract. It has we can set an URI for the description, name, and all the stuff. So these functions, what we need to do, we need to build the data that we want to execute on our hotel contract, send it here, and they will, and this contract will execute that data on the hotel contract. And we also made an event that the hotel was called. What transfer hotel, no need much explanation here. You change the ownership of the hotel that is registered on blockchain. And then we have the view public function, right? So this function, it doesn't cost you anything to call it. You can call it all the time you want it. So this is to get all the hotels that are registered here. You can get the hotels land, get the hotels, and get the hotels by manager. Yeah. So this is the whole 1.3 index smart contract. Let's look at the abstract contract that I was talking to you before. So this is everything you need to know, right? To communicate with the smart contract. And I need to know only the name of the functions and the parameters that it's going to receive. With this, I can generate the function signature, and the EVM is going to know which function I want to call when I communicate with the contract. And this is the way that we are actually doing on our JavaScript libraries. We create the hotel with the entire contract, but then we just use the index. I think I have it over here. Okay, this is the hotel contract. So, this is the contractor. This is what we are sending the manager that is going to be managing the smart contract, the data URI, and then the index, I don't remember for what's originating. Okay, 1D3 index address. Yes, good. So this is everything that we are sending. Edit information implementation because this is an internal. Then we can destroy the implementation and change the manager. So all the functions later they are executed only by the through the 1D3 index smart contract. So what else I wanted to present? I think that was
I have a question.
that was kind of everything. Yeah.
Max gave very well presentation like of business context. Yes. Now we jumped very down into the lower technical stuff.
Yeah, this is
which is okay for some of us guys who know
Okay.
the smart contracts. But please, if we can have some middle abstraction, such as what is the hotel? If we have a Novartis chain, what is the hotel?
Yeah.
One building, one apartment, the whole chain. Can you just give this ideas here?
The hotel is the hotel. Like it's not a chain. It's just a hotel. It's like for it's a hotel, right? The thing we are representing here on the hotel, we are using this smart contract to share the data URIDs. Through this URI, you're going to be able to access the hotel availability, pricing, fares, all the stuff.
Augusto, I think the answer is we do have a presentation.
Yeah, also, they are going to talk about that.
Are you going to kind of talk about,
Yeah, they are, you are, that question is going to be answered when they present.
We will be talking about it.
Yeah.
But I agree that it's kind of a little funky that, I love a business perspective and now we're super deep down in smart contracts. We do need a middle ground.
It's because we wanted you to want that middle ground to have context for it.
Cool. So when you say delete hotel, is this going to impact also the history data or just the future data? Meaning the hotel is not anymore bookable, but what happens with the past?
All the transactions that happen with the hotel smart contract, they are going to be there. You can get rid of them, right? There is not going to be any personal information, nothing like that on these transactions. We are being super careful about what are we sharing here and to let the hotel have the control of what they are publishing.
Okay, and the second question. So you mentioned before that the index will be modified or changed or administered somehow centrally. Right, so not anyone participating on a network can introduce a change and eventually let this get another branch. Did I understand correctly? Or because, for example, if we want to change what a hotel is, because you need, for example, merchant IDs, because they sell, they need to get the money somehow back. So if you have other parameters that need to be within the index, who is going to add this information in the index?
Well, that's a question about governance, which we will be pretty much to be decentralized also. Right now, this is managed only by our multi-signature, but it will be awesome if we can have multi-signature managed by hotels that are using our platform, and they can take care of what do they want to have on 1D3, right? We can decide all of us together. First, we need to build all the stuff. And then, but yeah, that's where we are going. We are, of course, going for a decentralized governance, because it doesn't make sense, right? If you have a tool like this, are you just using it being managed by only 1D3 or 3 or 4 guys?
Any other questions?
A question there in the back. I go there.
For the hotel contract with the data URI, how specific is the information that goes in? Are we using the smart contracts to handle the nitty-gritty of running a hotel, or is this just for registering a hotel and then information about room availability is handled off-chain?
All the stuff is handled off-chain. The only thing that we are sharing, that we are using blockchain to share information, right? To share trusted information. You know that this data URI was published by the hotel, because the hotel is the only one who can set where the information is going to come from. And then, of course, then the information that they are going to publish there, it's their responsibility, right, to follow a certain standard, or they can have it on whatever standard they want.
So the URI is more like a feed from the hotel of their up-to-date information, or where you find their up-to-date information, correct?
Exactly. That URI is going to give you access to all the hotel information, basically. And well, you can actually later build some very good cryptographic solutions. For example, you can sign all the data that you are sharing, and you can actually verify that this data was shared by the hotel. This is what we want. We want to share trusted information. We want to know that this is the information that the hotel put us there.
Is there somebody from NU Cipher here today? Maybe you can ask.
I think, yeah, we have no Cipher people. Yeah, they were coming, I think. Okay, no sure today.
So I also wanted to just say very, very quickly. So we say hotel, hotel, hotel all the time. That's our primer, but the infrastructure for the airlines will not be different at all. So it will be an airline contract. So our goal is to create the infrastructure for the distribution as similar as possible between all kinds of different parties. And again, of course, the data standards, data formats will be, in some cases, wildly different. Some of the challenges that are different, again, in the hotel industry, in the airline industry, is perhaps search and other things. But as much of the stuff that we're building here should be similar. That's at least our goal. We're still figuring out how exactly, where that line is going to be. But as much of it is going to be similar, hopefully.
Awesome. Gracias, Max. So I think, yeah, this was it. Sorry for kind of presented so disorganized.
Here's a question.
Okay.
Sorry, Max, you might want to answer this afterwards because it might get a bit heated, but how are you going to not just replicate the bloat of the HTNG madness that we're already in if you're trying to get the data sets for hotels, cruises, airlines, resorts, golf courts, spas, all into the same kind of model? Because anyone that's navigated the HTNG standards is in that kind of nightmare space.
Which company are you from?
2P Ventures, we spoke on email.
Oh, right. We do have someone from SIDE here.
And I know you just did the HTNG, you announced it the other day.
Yeah. So again, our goal is not. Oh, there you go. Yeah, thank you.
We can get an answer.
Okay. We can get an answer.
Our goal is to create the infrastructure on the blockchain, some common rules that everyone will be able to use. How the standards will be developed on top of that, we don't know, and we don't want to know. You guys, so what we're creating here, the analogy that I use often is Conway's game of life, right? It's what it's called a cellular automata. So it's basically a computer game in a sense, right? Where there are 4 rules, but based on those 4 rules, an amazing complexity can be created. So what we're creating here is just a few simple rules that everyone will be able to understand, whatever your industry is, whatever you're thinking about, how your business should work is, you should be able to implement it. You should be able to take TCP/IP and do whatever you want with it at your company, right? So our goal is not quite to say, hey, we're gonna unify and everything will be standardized and yada yada. No, absolutely not. What we're saying, hey guys, here's a common infrastructure. Any of you can use it in whatever way you want, unless you don't just don't break the rules. Or you won't be able to break the rules. Duh, right? It's a blockchain. But use it whichever way you want. We will facilitate this conversation. We will facilitate, as you can see today, the collaboration, right? We will bring people together into one room and hey, let's play together, right? But that's about it. We don't want to dictate the rules. That's not, again, that's not our philosophy. That's not our goal to like say, hey, this is exactly how it's going to be. So we don't want to be kind of like all those attempts in the past to standardize things. So I don't know if I'm answering your question. Kind of. Yeah, yeah. Absolutely.
So hello, I'm Nicola from Sant, and we are building actually an HTNG adapter for Winding Tree for hotels only. And it's thank you. So the way it starts is pretty much that we have minimal support for the data formats, and basically the hotel decides what to share and the use case that they want to do, and depending on whether where this goes, we can implement further support with the format. It's not necessarily fixed in the beginning, so we are starting with small steps and moving forward.